Greetings to all. My name is Chandana, studying 8th Sem Civil Engineering in Sri Venkateswara College of Engineering, Bengaluru. Today I am going to present a technical seminar on transparent aluminium in building construction. Introduction. Our understanding of construction materials and their environmental impact has never been greater than the day we live today. Construction materials are getting more complex, innovative, and futuristic. Some draw inspiration from the nature, while some are wholly novel and constructed with alien components. There are so many cutting edge materials emerging right now that it's impossible to keep up, but do have the potential to revolutionize architecture and development today, tomorrow, and in the future. Transparent aluminium or aluminium oxynitride is a ceramic material that has the unique properties of being both transparent and incredibly strong. This material is made from powder which is pressed and heated to form a solid. It is then polished to a clear transparent finish. In building construction, transparent aluminium can be used in a variety of applications. One of the main advantages of this material is its strength and durability. It is scratch resistant and can withstand impacts from the windborne debris, hail, and other hazards without cracking or breaking. Objectives. Transparent aluminium is a versatile and high performance material that has potential applications in many areas of building construction. Transparent aluminium can also be used as a security barrier as it is highly effective at stopping ballistic threats. Transparent aluminium can provide a high level of both safety and energy efficiency. It can also be used for providing an outer layer that is highly durable and resistant to weathering. It can reduce heat gain and glare while still allowing natural light to enter the space. This can help to improve comfort and energy efficiency while reducing the need for artificial lighting and cooling. Literature survey. First, transparent ceramic materials for high performance building envelopes, published in the year 2022. This review article focuses on transparent ceramics, including aluminum oxynitride, as potential materials for high performance building envelopes. It provides an overview of the properties, processing techniques, and potential applications of these materials in building construction. The author highlights the benefits of using transparent ceramics over traditional materials such as glass and polymers, and discuss some challenges in their application such as cost and durability. Second, transparent aluminium and its potential for sustainable building design, published in the year 2021. This review article examines the potential of transparent aluminium, especially aluminum oxynitride, in sustainable building design. It provides an overview of the properties, manufacturing processes, and applications of the material in building construction, including windows and roofing systems. The author discussed some challenges and opportunities in the use of transparent aluminium, such as cost, energy efficiency, and environmental impact. Third, transparent aluminum oxynitride as a building material, published in the year 2020. This review article covers the potential of transparent aluminum oxynitride as a building material. The author provides a comprehensive overview of the properties of aluminum oxynitride, including its structural properties, optical properties, and thermal properties. The article provides an insight into the potential of transparent aluminum as a building material for sustainable and energy efficiency buildings. Fourth, transparent aluminum oxynitride, published in the year 2019. This article provides an in-depth review of the properties, manufacturing processes, and applications of transparent aluminum in various fields, including aerospace, defense, and building construction. The author discussed the challenges and advantages of transparent aluminum compared to other transparent materials such as glass and polymers, and present some recent developments in the synthesis of transparent aluminum, including hot press sintering, spark plasma sintering, and microwave sintering. The article also covers some potential applications of transparent aluminum in building construction, such as transparent structural components, roofing, and cladding system. These were the four literature surveys from the past 4 years. What is transparent aluminum? It is a crystal clear and ultra hard transparent ceramic material that is manufactured via powder processing. It has been fielded in many defense systems and is available commercially in large sizes and quantities. Transparent aluminum or aluminum oxynitride is an optically transparent aluminum which is crystalline substance made of aluminate powder alloys. Aluminum, being a popular construction material, becomes aesthetically pleasing when a transparent element is added to it. Transparent aluminum is used in various applications like infrared optical windows, sensor components, and the military defense industry. This topic discusses the features and applications of transparent aluminum in the construction industry. Types of transparent aluminum. There are majorly five types of transparent aluminum available. First, aluminum oxynitride, a ceramic material that is highly transparent to infrared light as well as visible light. Aluminum oxynitride is often used in military and aerospace applications due to its strength and resistance to impacts and scratches. Second, aluminum hydride, a metal hydride with a high hydrogen content that can be used as a reversible hydrogen storage material. It is transparent in the near infrared region and has been investigated for the use in solar cells. Third, aluminum doped zinc oxide, a transparent conducting oxide that is used as a replacement for indium tin oxide in electronic and optoelectronic devices. Aluminum doped zinc oxide is highly transparent in the visible range and is also electrically conductive. Fourth, aluminum nanoparticles. These are tiny particles of aluminum that are highly transparent in the visible region of the spectrum. They are being researched for the use in solar cells as they could potentially replace expensive materials like silicon. Fifth, transparent aluminum alloys. A certain aluminum alloys have been shown to be transparent to visible light. These alloys are typically made by mixing aluminum with elements like magnesium, zinc, or copper. They are being studied for use in applications like windows and displays. Material composition. Aluminum oxynitride is transparent ceramic composed of aluminum, oxygen, and nitrogen, such as varying the aluminum content from about 30% to 36%, which has been reported to affect the bulk and shear moduli by 1 to 2% only. Material requirements for manufacturing transparent aluminum. First, high purity aluminum. The starting material for transparent aluminum is pure aluminum having a purity of at least 99.99%. The high purity of aluminum ensures that the final product has a uniform composition and does not contain any impurities that could reduce its optical transparency. Second, nitrogen gas. Nitrogen gas is used during the manufacturing process to convert the aluminum into aluminum oxynitride. It is essential to maintain a controlled environment during the manufacturing process to ensure that the final product has the desired properties. Third, oxygen gas. Oxygen is used during the manufacturing process to control the oxidation of the aluminum. The precise control of oxygen levels is necessary to ensure that the final product has the desired level of transparency. Fourth, high temperature furnace. Transparent aluminum is manufactured using a heat and pressure process that requires a high temperature furnace. The furnace must be capable of maintaining temperatures of up to 2200 degrees Celsius and high pressures. Fifth, molding equipment. The manufacturing process involves molding the aluminum oxynitride powder into the desired shape. Specialized molding equipment is required to ensure that the final product has the desired shape and dimension. Sixth, polishing and grinding equipments. The final step in manufacturing transparent aluminum involves polishing and grinding the surface to achieve the desired level of transparency. Specialized equipment is required for this step to ensure that the surface is smooth and free of scratches. Manufacturing process of transparent aluminum. Transparent aluminum or aluminum oxynitride is produced by combining aluminum, oxygen, and nitrogen. The manufacturing process involves pressurizing aluminum oxynitride powder to 15,000 pounds per inch in rubber molds submerged in hydraulic fluid. The obtained material, which is molded and opaque, is heated to 2000 degrees Celsius and kept this temperature for 2 days. Once cooled, aluminum oxynitride emerges transparent, which is then ground and polished for extra clarity and strength. Features of transparent aluminum. First, transparent aluminum or aluminum oxynitride is a transparent polycrystalline ceramic with a cubic spinel crystal structure. Its chemical formula is Al2O27N5. Second, aluminum oxynitride is produced by combining aluminum, oxygen, and nitrogen. The manufacturing process involves pressurizing aluminum oxynitride powder to 15,000 pounds per inch in a rubber mold submerged in a hydraulic fluid. Third, aluminum oxynitride can be fabricated as rods, tubes, plates, windows, domes, and other forms using conventional ceramic powder press techniques. Fifth, the grinding and polishing of aluminum oxynitride during its manufacturing improves its impact, resistance, and mechanical properties. Properties of transparent aluminum. Transparent aluminum is optically transparent, that is 80% transparency over the region from near ultraviolet to visible and near infrared wavelengths. The material remains solid up to temperature of 1200 degrees Celsius and it is highly resilient. It is 3 times harder than the steel of the same thickness. Transparent aluminum is delamination resistant and it has less interlaminar residual stress. As transparent aluminum is crystal clear, it provides outstanding refractive index homogeneity over large areas. It is scratch resistant and has high life expectancy. Physical properties of transparent aluminum. Physical properties include compressive strength, flexural strength, fracture toughness, noob hardness, Poisson ratio, shear modulus, and Young modulus. Compressive strength of transparent aluminum is 2.68 gigapascal. Flexural strength is 0.38 to 0.7 gigapascal. Fracture toughness is 2 MPa per meter square. Noob hardness is 1800 kg per mm square. Poisson ratio is 0.24. Shear modulus is 135 gigapascal. Young modulus is 334 gigapascal. This is a table showing the typical properties of transparent aluminum. Comparing the physical properties of transparent aluminum with silica glass. Here, comparing the optical properties of aluminum oxynitride and spinel ceramics. The table shows the properties of transparent aluminum comparison with other materials. Methodology. The methodology for using transparent aluminum in building construction involves the following steps. Design and planning. The first step in process is to determine the scope of the project and the areas where transparent aluminum will be used. This will help architects and engineers to design the building and create the drawings necessary for the construction. Second, material selection. Once the design is complete, select the appropriate type and thickness of transparent aluminum that can meet the design requirements. Third, fabrication. The next step is to fabricate the transparent aluminum sheets according to the design specifications. This process involves cutting and shaping the sheets as well as polishing and coating the surface to improve its durability and visibility. Fourth, installation. Once the transparent aluminum sheets are fabricated, they can be installed in the building. This step requires specialized installation techniques, including the use of specialized adhesives to bond the sheets to the framing and sealing the edges to prevent water infiltration. Fifth, testing and inspection. After installation, the transparent aluminum should be tested and inspected to ensure that it meets the design requirements and industry standards for quality and safety. Sixth, maintenance. Finally, ongoing maintenance is necessary to keep the transparent aluminum in optimal condition. This includes regular cleaning and inspection to identify any signs of wear and damage, and repairing or replacing damaged sections are necessary. Advantages of transparent aluminum in building construction. High strength. Transparent aluminum is incredibly strong, making it reliable material to use in building construction. Transparency. This allows natural light to enter the space and provides better aesthetics. Safety. Transparent aluminum can be used in the construction of bomb blast resistant glazing, making it an excellent option for buildings located in high security areas. Durability. Transparent aluminum is resistant to both abrasion and corrosion, making it a long-lasting material option. Energy efficiency. Transparent aluminum can help to reduce heat gain and glare, resulting in better energy efficiency. Disadvantages of transparent aluminum in building construction. Cost. The cost of transparent aluminum is relatively higher than the other materials. Production time. Creating transparent aluminum is time-consuming process. Third, limited applications. Transparent aluminum is most commonly used for heavy glass, which may limit its versatility in some construction projects. Specialized installation. Transparent aluminum requires specialized installation techniques and equipments, which can add to the cost of the project. Maintenance. Although transparent aluminum is highly durable, it may require regular maintenance to prevent scratches and can result in poor visibility. Uses of transparent aluminum in building construction. It is used for windows and skylights, baffles and diffusers, facades and claddings, safety and security, and solar control. Uses of transparent aluminum in other sectors. Various defense applications like sensor windows, transparent armor, windows for laser communications. Second, semiconductor and related applications, refractories, insulators and heat radiation plates, optoelectronic devices, metal matrix composites, translucent ceramics, thermally conductive fillers, power and multi-clip modules. Talking about the case studies all around the globe. First, Apple Store Istanbul. The Apple Store in the Istanbul features a unique inner shell made up of transparent aluminum. The pans are made from aluminum oxynitride and have a thickness of only 14 mm, making them lightweight and durable. The transparent aluminum provide a high level of light transmission while giving the building a distinctive appearance. Second, the Louvre Abu Dhabi. The Louvre Abu Dhabi features a dome structure that is covered with a layer of transparent aluminum. McDonald's flagship store, Chicago. The McDonald's flagship store in Chicago features a unique facade made of aluminium oxynitride. The facade is composed of 1-inch thick aluminium oxynitride panels that are suspended in front of a layer of LED panels. Bullitt Center, Seattle. The Bullitt Center in Seattle features a glazed facade made of aluminium oxynitride. One Central Park, Sydney. The One Central Park complex in Sydney features a large helostat covered in aluminium oxynitride. The helostat reflects the sunlight into the central garden, providing natural light to the building interiors. These were some of the few examples of transparent aluminium used in building construction across the globe. Now coming to the conclusion. In conclusion, transparent aluminum has been used in building construction to provide excellent optical and mechanical properties while meeting energy efficiency requirements. Its unique appearance and ability to transmit natural light make it popular choice for facades and other construction applications. However, transparent aluminum, also known as aluminum oxynitride, is a material with unique properties that make it potentially useful in building construction. It is harder and more scratch resistant than traditional glass while also being transparent and able to withstand high temperature and impact. This makes it suitable for use in windows, skylights, and other structural glazing applications where durability and safety are important. Additionally, its thermal insulation properties can help to reduce energy costs and improve building sustainability. These are the few references for this technical seminar of transparent aluminum in building construction. Thank you.